Let's stop sharing. Okay, it's your turn. Would you want to be first? Don't be shy. Okay, I will pick one for you. Maybe let's start from the right, from your left to right. So maybe you first. It's okay, up to you. You can, if you have presentation, you can show me, but you can show mathematical. Okay.
Okay. Can you hear me? Can you hear me? Like, am I supposed to speak to the microphone or?
Maybe please turn your microphone on. So
it's already on.
I may have no idea now, but when I go back home.
Mm-hmm. Yeah, exactly. Okay. Because on the call it says that I'm speaking, so I'm just gonna present. Can I share my screen? Is that all right?
Yes, you can. Please.
Okay. Okay. Okay, so this is the presentation that I'm gonna do. It's about abalone measurements. So first of all, I'm gonna talk about the scope of the project quick. Then I'm gonna go ahead and speak about data exploration. Then I'm gonna talk about creating the model, and then the predictions and the testings. So in the first part, so here's a quick context. So abalone, it's a seafood. And traditionally, determining the age of an abalone is very tedious work because we have to cut it and stain it, and then we have to count the numbers of the rings through a microscope. And in this presentation, I want to present a more efficient way to determine the abalone by using previously collected data on other measurements. So, for example, the sex, length, diameter, weight of the shell, etc., etc. So. My main goal is going to show that we can use the data of previously collected samples and to find the correlation between different variables. That way, instead of having to go through the hard process of everything like cutting the shell and looking at the rings, fishermen can probably will probably be able to use the measurements and prediction tools to determine the age of the abalone. So that is Wolfram repository under the name abalone measurements. So for the data exploration, it was fairly simple. To be honest, I didn't have pretty much anything to do because the data was numerical and there wasn't any missing value. So the only thing that I had to do was remove the units for analysis purposes. So it was just about removing the units and partitioning the data set, shuffling the values, and dropping the age column, which is the variable that I want to predict. So for the data exploration, my plan was just to explore it, to just have a rough idea of the key values of the distributions for every variable. Plotting the distributions will give me and eventually a client, if I have to work with the client, a general idea of how the population is distributed. And it will also allow to remove the outliers, if any, and make sure that the study it sampled is more relevant. I also plan to do a quick clustering on the data set just to see if there were any subgroups within the population. I don't think it's going to help with the prediction, but it's just for visualization purposes and maybe understanding the population a little bit more. So to create the model, it's fairly easy. Mathematica is very high level when it comes to this. So I'm just going to use the predictor function. The predictor function, you can pass in the data and you can specify the method. So here is where I'm going to try to change the method and see which one is the best one. So from what I found, apparently random forest and linear regression can be very effective. I still didn't put it really into practice, so this is something that I'm going to practice and test later on. And here is a sample of what I did. So after building the model, we can actually put it into practice with the testing set, and it will all be about finding the best combination of variables to establish the most accurate model possible. So here, it seems like the model is very good at what it's doing because it's fitting the data very well, and the predictions are very, very accurate. I think it's all going to depend on the parameters that I'm going to use. So I think in my study, I'm just going to try with different combinations of parameters and methods for the prediction, just see which one is the most accurate. And then I'm going to display that in a way that's going to be interactive to the client so he can play with that and see what combination is the best. So that's pretty much it. Yeah.
Okay, great. Thank you.
Thank you.
Okay, and you maybe you on the back, please.
I'm still cleaning up the data, exploring what I can do to add something more to get some interesting insights. Right now, I already feel this and have different metadata now separate. Next step would be analyzing what figuring out if I can find the data in a meaningful way.
Okay.
I understand. Yeah, it's been, so it's basically like the region.
The region. Mm. Yes. As I remember from the last time, you are the one who trying to want to visualize it, right? To
Yeah.
find which
Exactly, like I want to find an interesting situation, so I don't know yet the prediction.
um um mm, I'm not sure if it's okay or not from the last time. I try not to suggest you to do unsupervised learning because for the last time, as I remember, I suggest you to find more feature, more dimension to add into to this one.
I was looking at that, I didn't find any data yet.
Mhm. Construction period. Anyway, maybe I will come back to you. Okay, thank you. And you, please. Um, maybe you can be there and you just speak. Okay, maybe sure if you want to. Oh,
So, my data set is about this one is customer behavior. I found it on the Kaggle. So
could you join the Zoom
yeah, I already joined.
and share to?
My laptop cannot share the screen for some reason. And
Oh, you cannot share. Can you show me what it looks like? ลองกดนะครับไปที่ตรงนี้แล้วก็แชร์เนี่ยเนาะแล้วก็อาจจะแชร์อันนี้เลยก็ได้ Okay, cool. So
So I'm trying to do in Python because I don't really impressed with mathematics. Probably I will the contract to do it in mathematics. Basically, I'm trying to predict whether or not the customer gonna purchase a product that being offered by a company. And in this data set, 1 means the customer purchased the product, and 0 means they gonna purchase the product. So I'm trying to predict whether they're gonna purchase the product or not. So this is what I'm doing. So I'm putting user ID and then changing the gender to 0 and 1. Splitting in the frame somewhere and trying to train and test the data. And I think our result of
Oh. 80% accuracy.
So is that good enough? Because I want to try something that I heard of, like this picture engineering. I heard that you can do based on like an existing for example, this one.
For feature engineering, actually, I will tell you guys first. His problem is actually he wants to predict which customer will purchase this particular product or not. As you can see from this one, this is the target, his target. He wants to predict from this one, and the results show that with using logistic regression alone, it can do 80%. But he wants to do some kind of feature engineering. What is that? Okay, we have estimated salary, age, and gender, and what is the feature engineering you want to do?
Like maybe from age, I can take like the bottom like 25% and make like your maybe take the top 25% of age.
Make
like that.
From the bottom 25% to do what? Sorry.
So feature engineering effort. So I want to ask. So I read that this like can create a new column, right, based on an existing column, right? So,
Oh, actually, feature engineering it's like a okay. He just want to do feature engineering. The word feature engineering is actually you maybe combine two columns to create another one. Yes, it's correct. But the concept of doing that, you may have to know what you are going to do. For example, if there is some feature that look like this one, for example, I will draw a histogram of maybe not histogram, but some data that align in this kind of thing. And this is X, this is Y. In this case, maybe I will take log. After taking log, maybe it can transform this curve into this linear line here, like something like this. This is feature engineering. Or maybe if there are two columns, for example, let me think. For example, let's say we have salary here, and some kind of payment. You may have payment. Let's say that the first person got 1,000, maybe 1,000 bucks, and the payment is this much. Another person is this much, but their payment is 80, just 80. In this case, maybe I don't want to feed this number alone. Instead of this one, I transform this payment into some kind of payment ratio because I want to see they pay something much or not compared to their salary. So I take this column, divide by this one to create another one. This is the feature engineering. Let's pay ratio, something like AR. So the first one is 0.8, right? The second one is 0.8. So in this case, number is the same. So this is just example of feature engineering.
So you have to like have two columns that correlate with each other. Like,
It may not have to be like that way, but you have to know. Well, in your case, I still have no idea what to do with that one.
okay. So like, is this good enough? Like the good latest regulation.
Okay, I challenge you to improve. Let's think about this number is the baseline, and can you improve this thing to be maybe 90%? Or I'm not sure. Is there are other feature for this customer? For example, can you show me? You go back to this. Could you go up? Okay, maybe this one. In this data set, do they give you this one alone, or they are the other file or something like that?
I don't know. This is all. So like, it's just like 5 columns.
5 column, or are there any other data?
No.
No.
This is like the all the.
Okay. Okay, maybe you can improve, find another model to make it better. Yes. Or I suggest you to change it, because I think this one is quite simple. Yes. Oh, see you. Okay, next please. You have to put it. Yes, actually we have talked already. Yes. I'm not really here, I think. Yes.
Okay, maybe I try to apply many models and see. Thank you so much.
I hope you're doing well. Maybe you can ask TA if you want my help. Maybe you can.
Yeah. And I also try to do like clusters of, because it's like per US counties. So I tried to do clusters of like counties that might look alike, and then try to see if there are models that represent more each cluster. Is that like a good idea?
Yes, I think it's a good idea. Actually, to be honest with you, not last time, in year 2020, some students do the project before. They try to cluster the clustering, and what they found is it's quite interesting. I don't want to spoil.
That's it. It's a good day.
Yes.
Thank you so much.
Good luck. And okay, it's your turn. Sorry, could you turn on your microphone? Okay, thank you.
This is an air pollution dataset from my hometown, and last week I have cleaned the data and filled the empty cells from the data by using like mean imputation per column. and I wanted to predict like the next period or the next month of the pollution data. So I think that's all for the progress.
Okay. So what is your target?
I want to predict the next month of these variables.
Oh,
Like the
so it's like a time series, right?
yeah, like a
Oh,
PM10,
okay.
PM 2.5, SO2, CO, O3, and O2. That
Okay.
variable.
Okay, good. It seems to be no problem. I suggest you to use, maybe you can use LSTM as we learned from this class, or maybe it's up to you. We can transform it to be maybe not the, or maybe yes, maybe you can use LSTM or anything.
Can I use like after I change data and I can find it out like
Yes, you can do.
oh really?
Okay, thank you, and sorry for doing it great. See you.